Hello and welcome to the latest developer diary for my current solo project. So last time was focusing on the terrain generation side of things. This time around, I'm going to take a look at the movement side of things, because that's been the current area they've been working on and has it's involved a lot of maths. It's involved a very large amount of maths. So this is where we're currently at with it. So the environments are spawning. I've been doing a bit of tweaking on how the environments sort of blend together. You'll also notice that this is the first example where it's actually starting to have different biomes, so it can select the different biomes and spawn those in. And that's just something where at the moment each biome, it picks one that's different. So once it gets to the end of a section of a biome, it then picks one that's different to the current one, picks a random number of segments of it to spawn, spawns that many, and then it will go and switch to another and different biome. And the train is now able to move, it's got min and max speed. It has a speed factor, so a 0 to 1. Has stuff like carriage spacing, and it actually now supports there being multiple carriages existing and them extending around corners. And then if I start it moving, and I'll just have it move slowly to begin with, it's able to then happily move, and as it moves into new sections, it will kick off spawning in new tiles. It also keeps track of the tile that the tail carriage is in and retains a certain number of tiles beyond that. And if we head to first person perspective, we can actually see what happens as we go around a corner. So this has taken a fair bit of iteration for getting the spacing of these. And we can see there are still cases where it does glitch and jump a little bit. So there's a few more tweaks and adjustments I'm going to need to make there, because things can still jump forward a little bit more than they should be able to. It's improved a lot from what it was, but is still an area that does require some tweaking. You can safely move between the carriages, which that was a little bit of a challenge, because you're a rigid body that can move around on other moving platforms, which is quite a challenge there. These carriages, these are the current sort of placeholder models, and you can't go downstairs on these currently. I'm planning on rebuilding all of these. So I'm going to rebuild them in a different program, and because we do still get a little bit of glitching with the movement. And I think what's happening there is at times the carriages are sort of jumping forward a bit too much. So that's something where I need to do a few more sort of tweaks to that, but it generally handles pretty well. Like, I'm really happy with how it looks when it moves around sort of the turns there. That visual is working way better than was expecting it to. One of the things that it does run into, because of how long the train moves for, is it very rapidly can get to a point where the inaccuracies with floating points becomes a factor. Because the further we move from the origin, the larger a step is with those floating point values. So we can get it, at the start, the carriages are a consistent spacing, but that very quickly can expand out and out and out and out and out. And it goes from being, these are 5 meters apart to these are 30 or 40 or 50 meters apart. So I'm going to need to be making some changes there in terms of having it take more of a looped approach, be centered more around the origin. That's stuff where it's quite easy for me to adjust and mess with those things though. So I'm reasonably confident in being able to make that work. In terms of how the code works, so much like I did last time, I'm going to make the code for this stuff available. So a core part of how it's working for positioning is each track tile has this array of track points. So each track point has its actual world space location and its path distance, so how far through that segment of the path, that area is. That allows me to easily locate points, things like that. So with that, I have all that data built up that's procedurally generated, so it's not stuff that I need to hand build, which means if I did more complex tile shapes, would be able to, I'm pretty confident, handle that if need be. So that's a core part of it. Then the driving of the carriages gets handled from a central point. There's one overall controlling script that's positioning everything. And so what happens is, so fixed update, every fixed update, and I'm doing it there just because everything with how it's moving, I think it's going to result in it moving a little bit better and more consistently. And especially because we've got a player on top of it, so there's the rigid body interactions there. So I take how far I am through a tile. I advance that based upon my current speed. And then I check to see if that's gone beyond the end of this tile. If it has, then I remove, advance to the next tile, and then update things from there. The update train position is where all the heavy lifting happens. So what it does is it goes through all of the carriages. So it starts with the head carriage, the one at the very front, because that does use slightly different positioning to the others. So it uses this get engine position data. And this one works a little bit differently to the stuff used for the carriages, because what it does is it provides that distance, that path distance in a tile to it, and it finds which one of the line segments. So even the areas where it's a curve, I actually just comprise that as a lot of line segments. So it takes those line segments, and then from that, it works out which index we're at. And so each carriage, if we take a look at it, an individual carriage has 2 markers in it. So every single carriage must have 2 markers in them. And if we have a look at the prefabs for it, so each one has a head marker and a tail marker. And it's these markers that essentially run along the track. So the very start, very end, the middle sections don't actually have to be on the track, but those head and tail markers are what gets placed and essentially slides along the track is effectively what's happening there. So we find the exact spot for the head marker based upon that distance. So we use that path distance, that gives us our exact position for the marker there. Then we find, so using essentially a circle, that the radius of the circle is the distance between that head and tail marker. We draw a circle from that head position to find where that circle intersects, and that gives us the tail position. And this was one of the really tricky parts. This was actually a very tricky part because that could be in our current tile or it could be in the previous tile. So we do need to check twice. It also is reasonably complex because I need to do a bit of a search through the potential line segments to find the first line segment that is actually the correct one. So I'm doing an intersection of a circle with a line. That's what the logic here is doing. And there are 2 intercept points. But in my case, because of how it's all structured, the first intercept, the one with the subtraction, is the one that I can reliably assume is always going to be the closest. Now this strictly should be 1. Part of the reason it's 1.5 at the moment is because of that fact of the floating point error increasing and increasing. So once I fix the floating point error issue, I'll be able to bring that back down to 1. So I place the head marker exactly on the track, then I draw a circle, find where that intersects with the track, and that is where I can place the tail marker. Because what that does is to move the carriage, it works out the position, which the position is exactly halfway between the head and the tail markers, so I can average them. And it works out the angle. And the reason I work out the angle in this manner is so that I can construct a quaternion from it. And for anything other than an initial spawn, I smoothly move towards it. So I use a move towards and a rotate towards, so that the idea being to minimize jitter. That's really sort of the goal with it, is to make it that it's not jittering as much. So for placing the engine, that's how that works. Placing the carriages is a little bit more complicated because I can't use that distance, but that same intersection approach I can. So what I do is I first get the tail marker's location for the carriage in front of us, the previous carriage in this case. So I get that tail marker position, and then from there I find a location. So whereas for what I was doing with the engine, I would essentially anchor the head and then find the tail based upon the circle intersection. Here what I'm doing is treating the tail of the carriage that's in front of us as anchored, and then finding a circle based upon that carriage separation distance. And then that anchors that head position for the next carriage. And then I do the same process for finding the tail position. So it's continually doing these calculations. The cost so far doesn't seem to be prohibitive. It is something where there's bits that I might be able to use info from previous calculations to feed that through to be able to save some time there on future updates, so it's processing less data. The other thing that I'm thinking that I may end up doing is having this where the actual train calculations, having those potentially happen in another thread. Because that's something where it is largely decoupled. It is something where I could have those calculations run and I periodically grab the result of them and then apply them. So I'm not entirely sure whether I will necessarily do that, whether I'll need to do that, but it is a possibility. That could also be a use case for either a thread or possibly for even something like ECS or the job system. So I'm not entirely sure yet, but that is something that's in the back of my mind of here's a potential thing that I might want to do with this. So that's something that I'm looking at doing. So this is how I'm positioning the train carriages. And like with the previous one, I'm going to make this code available. There'll be a link up in the description to the gist for this. The other final little change that I needed to make is this idea of being able to auto-parent. Because if you don't parent the character to the train, then what happens is the train moves and the player doesn't, and the player ends up falling through the ground. It doesn't work quite so well. So what I have to do is I have to auto-parent. And it was a fairly quick and straightforward change for my character mode because I'm always doing this grounded check anyway. So what I now do is in the grounded check, if auto-parenting mode is enabled, then whatever I've found as the ground, I switch that to being my parent. So that means when I jump from carriage to carriage, I'm actually changing which one I'm parented to. So I go from being parented to one to being parented to the other. That's how I'm able to actually do those jumping between the carriages and not have, the train can be moving and I'm still able to do that without going flying off the train or things like that. Which is really good. I was concerned that was going to be something where I might need to be taking the train's velocity and blending that in with the player's velocity. I haven't needed to do that, which is great. So it's working a lot better than I was expecting it to there, which is a really good result. But that is the key stuff of how things are working. The next stuff I'm going to be focusing on is that stuff for addressing the things where the floating point error is creeping in. So having it be able to always run in a loop, having that movement be smoother again. So I want the movement to be really smooth as possible. I want to get rid of any of those bits of jittering that are happening. They're not frequent, but they're frequent enough that it's not something I'm happy with, so I want to get those resolved. And then I can get on with building kind of the majority of the game. This is actually only a fairly small section of the game. It's the high technical risk area. The other areas of the game are actually quite a known quantity, quite straightforward. This section is the really high technical risk. And this was the section where if this didn't work, it didn't matter with any of the rest of the stuff. So that's why I've focused on these bits first, because once I get this going as solidly as I need it to, then I'm very confident with the other sections, and the other sections will be quite straightforward to build on top of this. Performance is always going to be a bit of a concern there, but that's something where I'll get a better feel for that once I've got more of the areas up and running there in the game. Thanks, folks. I hope you found that really interesting to see. I'm going to be doing more of these because it's really cool getting a chance to be sharing the stuff for this. If you're looking for the code for it, I have, again, set these up as a gist. So the link for that's in the description below. You're free to use the code in your own projects. If they're commercial, non-commercial, you're very welcome to be using that code. If you've got questions on it, chuck in a comment below. Very happy to be answering any questions on this. And there's going to be many more updates to come. Looking forward to sharing more of the cool bits that I'm developing for this project. But until next time, bye.